Today we are looking at how explainable artificial intelligence can help humans innovate. If you're new to this channel, welcome. This is Mr. Singularity, where we explore the scientific and technological breakthroughs shaping the future as we know it. The area of artificial intelligence has developed machines that can drive vehicles, synthesize chemical compounds, fold proteins, and track high-energy particles on a superhuman level. However, these AI algorithms cannot explain the reasoning mechanisms behind their decisions. A computer that manages protein folding and also teaches researchers about the laws of biology is much more useful than a computer that folds proteins without clarification. As a result, AI researchers like me are now turning our efforts to build AI algorithms that can describe themselves in a way that humans can understand. If we can do so, I hope that AI would be able to reveal and educate people on interesting information about the environment that has not yet been uncovered, leading to new inventions. Learning from experience. One area of AI, called reinforcement learning, explores how machines can learn from their own experience. In improving learning, the AI experiences the environment, getting constructive or negative input based on its behavior. This method led to algorithms that independently learn to play chess at a superhuman stage and to massively prove mathematical theorems without any human guidance. In my work as an AI researcher, I use reinforcement learning to build AI algorithms that learn how to solve puzzles like a Rubik's Cube. By reinforcement learning, AIs train individually to solve problems that even humans are struggling to solve. This has had me and a lot of other researchers thinking less about what AI can learn and more about what humans can learn from AI. A machine that can solve the Rubik's Cube should also be able to show humans how to solve it. Peering into the black box. Unfortunately, the minds of superhuman AIs are actually out of control by us humans. AIs made bad students, and that's what we in the computer science community call black boxes. AI merely speculates solutions without providing explanations for its solutions. Data scientists have been attempting to open this black box for decades, and new research has shown that certain AI algorithms think in ways that are similar to humans. For example, a computer program to recognize animals will learn from various types of eyes and ears, and will use this knowledge to accurately identify the animal. The attempt to open the black box is called the Explainable AI. My research group at the AI Institute at the University of South Carolina is involved in creating an explanatory AI. We work extensively with a Rubik's Cube to do this. The Rubik's Cube is essentially a problem of pathfinding. Find a path from point A, a scrambled Rubik's Cube, to point B, a set Rubik's Cube. Other pathfinding problems include navigation, hypothesis proofing, and chemical synthesis. My lab has set up a website where everyone can see how our AI algorithm solves the Rubik's Cube. However, it will be hard for a human to learn how to solve the cube on this website. This is because the machine is unable to inform you of the reasoning behind its solutions. Solutions to the Rubik's Cube can be broken down into a few general steps. The first step, for example, could be to shape a cross, and the second step could be to bring the corner pieces in order. Although the Rubik's Cube itself has more than 10 to the 19th power combinations, a generalized step-by-step guide is very easy to recall and is useful in different situations. Approaching a dilemma by breaking it down into stages is also the default way people describe problems to each other. The Rubik's Cube blends naturally into this step-by-step structure, which allows us the ability to open the black box of our algorithm more quickly. Creating AI algorithms that can have this functionality will allow people to work with AI and break down a wide range of complicated issues into easy-to-understand steps. Collaboration is contributing to creativity. Our method continues the use of one's imagination to define a step-by-step strategy that is assumed to theoretically solve a complex problem. The algorithm then looks at each step and provides suggestions on which steps are feasible, which are difficult, and how the plan might be strengthened. The human then refines the original strategy using the guidance of the AI. The process repeats until the dilemma is overcome. The hope is that the individual and the AI will finally converge into a kind of shared understanding. At present, our algorithm is capable of understanding a human strategy to solve the Rubik's Cube, identifying proposals that do not work, and seeking alternatives that do. This provides input that leads to a step-by-step strategy to solve the Rubik's Cube that a person can understand. The next move of our team is to create an intuitive GUI that will allow our algorithm to teach people how to solve the Rubik's Cube. We aim to generalize this approach to a wide variety of pathfinding concerns. People are intuitive in a way that is unmatched by any AI. But computers are much better at their computing power and algorithmic rigor. This back and forth between a man and a computer exploits the attributes of both. I assume this form of partnership will shed a light on previously unresolved questions in everything from chemistry to mathematics, leading to new ideas, intuitions, and inventions that would otherwise have been out of scope. What's your take on this? Let me know in the comments below and check out one of these other videos. This has been Mr. Singularity, and I'll see you in the next one.